Now let's look at leaderless replication. In leaderless replication, there is no leader. The user can send out writes to several replicas, or there could be a coordinator which is going to send out writes to different replicas. Leaderless replication is used in DynamoDB. It is used in RAG, Cassandra. In a database configuration, this leader could fail. In that case, we might need to perform failover. Maybe this follower node would become newly elected leader, and all the writes need to go to this leader. In leaderless replication, you could say there is no failover. So the client is going to send out write to, let's say, 3 replicas, and for some reason replica 3 fails, but replica 1 and replica 2 actually accepts the write. And let's say we have configured it in such a way that 2 out of 3 acknowledgement is sufficient. In that case, we could say that the write is successful. So let's say we have another user, and the user is going to read from replica 3. Now since replica 3 failed, it is going to return old value. But then if the user connects to replica 2 or maybe even replica 1, then it would return the up-to-date result. So in leaderless configuration, it is common when we read something, we read from multiple replicas. So if we get different results from different replicas, how do we know which one is the newest result? We could use versioning to detect the newest result. But still, replica 3 has to be eventually consistent with the other replicas, right? In that case, 2 mechanisms are often used in Dynamo-style data stores. So the first one is read repair. The other one is anti-entropy process. So what happens in read replica is that when clients are going to read something, it is going to read from multiple replicas. So first it hits replica 3 and then maybe it connects to replica 2. Replica 3 is going to return old data, whereas replica 2 will get the newest data. And then the client will understand that in replica 3, the version is older than what we have in replica 2, and therefore we can go ahead and update replica 3. And in anti-entropy process, we could have background processes that constantly look for difference in data between replicas. Once it finds out there is some missing data in any replica, it is going to go ahead and update that replica.